Hello. In this video, you're going to learn how to create a fractal in Geometry Sketchpad and what concepts fractals can teach students in math classrooms. First, let's look at what fractals are. By seeing what fractals are, we can see what concepts we can teach students. So, using handy-dandy Google Chrome, I'll just type in, "What are fractals?" And Google tells me, if I scroll down to the fractalfoundation.org, that a fractal is a never-ending pattern. Fractals are indefinitely complex patterns that are self-similar across different scales. They are created by repeating a simple process over and over in an ongoing feedback loop. Driven by recursion, fractals are images of dynamic systems, the pictures of chaos. Geometrically, they exist in between our familiar dimensions. By looking at the definition the Fractal Foundation gives us, we can see that fractals relate to never-ending patterns, self-similarity, recursive definitions, and dimension. Never-ending patterns is easy to notice in this picture that the Fractal Foundation shows us. If we zoom in, we can see that we have triangle going inside triangle, going inside triangle. It's never ending. It's continually going. The next, self-similarity, this has to do with the iterations of fractals. What I mean here is each part of the fractal looks as the whole. So if you look at one portion of a fractal, you can see the entire image in that small portion. The next, recursive definitions, this has to do with how we create a fractal. So when we create our fractal, we start with one specific pattern. We do the same pattern to each part of the fractal, and we keep going to create our fractal. And dimension has to do with the fact that fractals don't necessarily fit in with our normal idea of dimension. Normally we think of lines having a dimension of 1, planes having a dimension of 2, cubes or pyramids having a dimension of 3. Well, fractals aren't really lines and they aren't really planes. They're somewhere in between normally. So it's difficult for students to come up with an idea of how to define dimension when you're working with fractals. So these, I think, are concepts that you can use to teach students by creating fractals. Hi, now I'm going to show you how to create a fractal in Geometry Sketchpad. I've opened up a new file, and the first thing I want to do is select the line segment tool, and I want to create a straight line. So to create this straight line, I'm going to hold Shift while I create it so it's nice and horizontal. And now I'm going to call its endpoints A and B by using the text tool. Now the first step is we want to create our first image, or our first object, or like the original iteration. Now, in this specific fractal that we're going to create, which is called the Koch curve, which is spelled K-O-C-H, if you want to Google it and find out more about the Koch curve, we're going to split this line segment into thirds, remove the middle third, and replace it with an equilateral triangle. So, first we need to divide our line into thirds, and I'm going to do that by marking A, then selecting A, then B, and going to the transform dilate. Now you can see that Geometry Sketchpad just pops up with you dilating it 1/2 the length, but we want to actually dilate it 1/3, so we're going to change it to 1/3. We're going to click dilate. And now we're going to do that again by marking B, and then B, then A, and dilating this one 1/3. So now we have points that are 1/3 between A and B on both sides. So we can label these points B prime, but I don't really like B prime, so I'm going to change this to X. And this one, which could have been A prime, but I don't like A prime, so I'm going to call it Y. So now we have our line segment split up into thirds. So now we need to remove this line segment, X, Y. So I'm going to do that by highlighting it and hiding it. So I'm going to hide it by hitting Control H. But that also highlighted the segments that I still need, so I'm just going to draw AX in and YB in. So now we need to create an equilateral triangle in the middle. So the way we would do that is by drawing a circle centered at X to A and then from Y to B. Now we can see that the radii of these circles is 1/3 AB. So both these circles have the same radii, so if we create new radii from X to the intersection and from Y to the intersection, these lines will also have length 1/3 AB and therefore be create an equilateral triangle just with the one of the bottom side of our equilateral triangle missing. So I don't need these circles anymore, so I'm going to hide them by again highlighting them and hitting Control H. I'm also going to name this point C. Let's scroll up a little so you can see it better. And I'm actually going to highlight this whole thing and drag it down just so it's more centered on my screen. So we can see now that this is our original object. And now what we want to do to create our fractal is create this image on every single side that we have. So in other words, we would split up each side into thirds, remove the middle portion, and create an equilateral triangle replacing the middle portion. Well, we could do that method that we just did to create this original one on each of these sides. That would be kind of tedious because we have 4 new sides now. We have AX, XC, CY, and YB. And so instead of having to go through that hassle of doing that whole pattern again, we can use our iterate command from the transform menu. So to do that, I'm going to select A and then B. I'm going to go to transform, iterate, and I'm going to send A to itself and then B to X. Now this creates the same pattern but on the side AX. And you can see these ghost images that it shows 3 different triangles because we're showing 3 iterations. That created the pattern on the first side, so now we need to do it to the next side, XC. So we're going to do that by going to Structure, Add New Map. We're going to send A to X and B to C. So this creates our pattern on the next line. So to do it for our third line, CY, again, go to Structure, Add New Map. Then A goes to C and B goes to Y. So again, one more map to do our final line, and this time A goes to Y and B goes to itself. So now you can see that we have our entire fractal with 3 iterations being displayed, because that's what it's telling us is being displayed. It's 3 iterations. What I like to do is go to Display and change it to Final Iteration Only. This means that now our fractal is showing only the 3rd iteration, not all 3 iterations in one picture. So now I'm going to say iterate. And that is the 3rd iteration of this fractal. Now we can move easily in between iterations of the fractal by hitting the minus and plus keys, which are right next to the backspace button on your keyboard. So say when I go to the 2nd iteration, I just hit minus. And so now you can see that we're at the 2nd iteration. If I want to go back to the 1st iteration, we hit minus again. Which we can see the 1st iteration did exactly what we wanted. Split our line segment into thirds and created an equilateral triangle in the middle. Now, if we want to go back up, we just hit shift and then plus. So 2nd, 3rd, 4th, 5th. I'm not sure if the Geometry Sketchpad has the ability to go any higher than the 5th. It might start to not be able to compute that many. So if we stretch it out as big as we can on this screen, you can see we have little teeny tiny triangles on every single line segment. So again, back to our original concepts of never-ending pattern. Our never-ending pattern is that we're creating triangles on the middle of line segments continually. The self-similarity is that if we look at each little portion, it looks like the entire picture. It's recursive because we defined it by taking our line segment, splitting it into thirds, and creating that equilateral triangle. And dimension because, as you can see, it's not really a straight line and it's not really a plane. So the dimension of this fractal lies somewhere in between. I hope that this fractal demonstration was very helpful and that everyone will use a fractal while teaching these concepts in a math class. So I hope you have a good day. Thank you and goodbye.